It's recording me right now.
It is, yes, it is recording me right now, Sam. All right, so here we go. The first section is 1.2. In this section, we have a lot of things that we need to cover. All right, here's a list of them that I'm going to put over on the side, and then we will go through them, okay? We're first going to go over the function definition. We're going to cover domain and range. A lot of these topics you will have heard before. We're going to cover continuity in a function. Oh, thank you. We're going to talk about increasing and decreasing. We're going to discuss what's called boundness in a function. Local and absolute extrema. Oh, let's get that on there, sorry. Local and absolute extrema. Symmetry. Asymptotes. And end behavior. Now, yes, this seems like an overwhelming number of topics, but the whole idea is that I would like for you to be able to look at a graph, and this is in general, this right here, but I would hope that you could be able to look at a graph after today, tell me what the domain and range is, tell me if the function is continuous or not, if the function is increasing or decreasing and where, if the function has what's called boundness, and we'll get to that, if the particular function has local and absolute extrema. Extrema are like max and mins. We're going to talk about the symmetry of a function, if at all it has asymptotes, and then what its end behavior is. Okay, so even though it looks like a large number of topics, we should be able to get right through them. We're going to probably take a break around, maybe around there just to kind of, and then come back to them, okay? All right.
I don't think you're going to explain.
All right, well, we'll give it a shot then. You're right, it does seem like a pretty lofty goal. Okay, all right, so basically a function. What creates a function? If we are looking at a graph of a function, do you remember from Algebra 1 what creates, or Algebra 2, what creates a function? How do you know a function is a function? It passes some sort of a test.
Vertical line test.
There you go. It needs to pass a vertical line test. Okay? This is an example of a function. If I lay my pencil down at any point, it passes through the graph one time. That's the vertical line test. Correct.
Yeah.
This is not a function.
Because it passes through place.
Correct. If I lay my pencil right there, it will pass through the graph in two places, here and here. That just means it's not. That's how we look at it graphically.
What if it's just straight up and down?
The line, it's just straight up and down.
Yeah.
Undefined.
It is that, you're right, the slope is undefined, and that is a vertical line,
So does it pass through class?
and that's going to be x equals just a number. Well, let's just say a. And no, that's not a function. You can't type. Typically, also, it'd be something that you could type into your calculator to graph. Can't type that into your calculator. Okay? The other one is, let's say we're looking at a table of data, and we're just looking at some numbers. Number pairs, let's just say, or coordinate points. So like we have X data, Y data, and we have like 0, 1, 2, 3, 1, 5, -2, and then we have numbers that correspond. Like that, okay? How can you tell by looking at numbers if it is a function or not? Does anybody remember?
No.
Something cannot repeat.
The
There you go. The x values cannot repeat. in this case, when x is 1, y is 5, and when x is 1, it's negative 3. That would be something like this over here. When x is 1, the function equals 5, and then when x is 1, it also equals negative 3. And because there are two different values for one x value, it is not a function. So as long as you remember that the x values cannot repeat, you're doing okay. All right? Those are things that create a function. All right? Okay, see, that's it. Check that one off your list. If you want to do a little check mark over there, that'd be just fine and dandy. All right, domain and range. Oops, sorry. No, that's okay. Sorry about that. Okay. And the nice thing is because this is being recorded, if you need to pause this and go back, then you most certainly can. Okay, I know that right now you're writing down the notes. Okay, domain of a function. Okay. What is the domain of a function? Does anybody remember? That is the x values. There you go. It is all the x values that you can put into a function to make it true. Okay? Let's do a couple of examples. Okay? Y equals x squared. If you just look at this, what x values can I put into there to make this true? Anything. And because you can put in absolutely any x value and you would get a y value,
The domain is infinity.
that's right. Well, the domain is from negative infinity to infinity. Always using parentheses, okay, with infinities. All right. What happens if I have something like this? F of x, or y, equals the square root of x plus 4. All right. Now, this particular function, it has a square root symbol. And there's something about square root symbols that we know that we cannot have under them. What can you not have under a square root?
Negative.
You can't have anything negative. So all of this under here has to be bigger than what?
1.
How about 0? Because it could be like a half. It could be really close to. It could equal 0. Because if x was 0, then that's fine. So basically, x plus 4 has to be bigger or larger than 0.
So it could be like negative 3 to infinity.
Well, let's solve this. How would we solve something like this to figure out what x is? What would I do?
Square it. Minus 4.
Subtract 4. There you go.
Oh, I thought you were talking.
Oh, no, I see what you're saying. No, I'm just doing this little part over here. So this says that x, as long as x is greater than negative 4, this function is true. So this right here is my domain. Another way that we would write this is we would say that the domain is going to be from negative 4 to infinity. Both of these having parentheses. Well, wait a minute. Can it equal 0? Can we take the square root of 0?
No.
Yes, that can equal 0. So right here, we should put that it can equal 0. Because if x is negative 4, so instead of a parenthesis, what am I supposed to have? Yeah, one of those little bracket things. Okay? So in your homework, you're going to get some problems, and you're going to have to algebraically look at them because they get a little tricky. The only other thing that you're going to see that might be tricky is if you have something along this line. Let's say that I've got f of x equals, the square root of x over x minus 3. All right, I have two things going on. What can a denominator not equal?
0.
Okay, so the denominator cannot equal 0. And x, in this case, must be greater than or equal to 0 also, right? Because of the numerator. Okay, does that make sense? Got two different situations going on. I have to worry about the denominator, and I have to worry about the numerator because I've got two of those special things. All right, well, if the denominator cannot equal 0, then x minus 3 cannot equal 0. Solve it like an equation and do what? Add 3. So this means that x cannot equal what number? 3. And x has to be greater than or equal to 0. So somehow I have to write my domain. If I think about a number line, okay, and I put 0 right here, and let's just say that's -2, it can equal 0, and I can have all of these numbers except for what number can I not have? 3. So right here at 3, it's almost like I have this gap or this hole. So now what I do is, like I did up here and here, I have to write what's called interval notation. So it looks like this. The domain, we start with the smallest number. Oops, 0, but we can equal 0. So we're going to go like this. 0 to what? 3?
Yeah.
But a parenthesis. Then we hop over 3, and then we go from 3 to infinity. Does that make sense? So now it's saying basically it's everything from 0 to infinity except that one little spot right there, there's a hole. And this symbol, technically it means union. Okay? So this, union, that. Those together make it up. And the parentheses mean that you can get really close to 3 but not equal to it. Okay?
Wait, don't move.
I won't move it. I'll just leave it there for a second.